Hello and welcome, everybody. Thank you for joining us today for our virtual meetup titled Expanding Horizons with Automated Computer Vision Modeling. In this session, we will go over image modeling problems, use cases, and the visual AI features in H2O Driverless AI 1.9. My name is Saurabh Kumar, and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker for the day. Sayam Bhutani is a machine learning engineer and AI content creator at H2O.ai. You would also recognize him from his very popular Chai Time Data Science podcast, where he interviews top practitioners, researchers, and Kaglers. Sayam is an active Kagler, ranked in the global top 1% in all categories, as well as an active AI blogger on the Medium and HackerNoon blogs with over 1 million views overall. Without further delay, I'd now like to hand it over to Sayam.
Thanks for the introduction, Iski. Let me quickly share my screen.
Yes.
Show my main screen. I should be sharing a browser window right now. Let me switch to Keynote.
Visible.
Is the Keynote visible?
Yes, it is.
Okay, thank you. Hello, everyone. Good morning, good afternoon, good evening. Thank you for joining the meetup. I'm pretty excited to talk about today's topic since this is one of my favorite interest fields inside of deep learning. And also because now that Driverless AI 1.9 is out externally, I can talk publicly more about how our products are handling computer vision. So this will include an introduction to computer vision and also a few small demos around what we are supporting right now and what we plan to support in the future. So this is today's agenda. I'll start by talking about H2O and driverless AI. What does an end-to-end machine learning workflow look like? How do we plan to tackle it using our products? I'll give a brief overview about deep learning and CNNs because I'll be throwing out a lot of jargon. So that'll help give some context about it. Then a little context about different domains under computer vision, different types of problems under computer vision, a few industrial use cases of this field, where is it being applied, if at all, today, and the computer vision tasks that are currently supported inside of driverless AI 1.9, which we had just released a few weeks ago, actually a few days ago. So H2O.ai is an open source leader in AI and machine learning, and our goal is to democratize AI by making your company an AI company. Here are a few stats about our products and our company, so to speak. Our products, not product. I'll just be talking about driverless AI, but these are for our products, which include open source and our flagship product driverless AI, as well as upcoming H2Q platform, which is more for business leaders or business facing people. And if you're interested in community events, we also have a large community of more than 180,000 meetup members. I'm guessing everyone would have joined through that. So please keep an eye out there as well if you'd like to join our meetups or other community activities. So these are, this is essentially the different generations of the products that we put out. I just want to point these out in case you'd like to check them out for other domains. Computer vision is a fresh domain that we're supporting right now, but these have been around for a little while. The first generation that came out was the open source products, and that's where the roots of our company started, which is why we like to think of our goal as democratizing AI, and which is why we are still the leaders in open source. After which driverless AI rolled out. It's still being updated. We're still adding a lot of features. And now we're also gearing up for H2OQ, which is right now in beta. So if you'd like to check it out, you can find more details on our website. Driverless AI and the open source products are intended for data scientists. And we cannot really democratize AI unless we are able to put it in the hands of more and more people. So that's a goal that we're hoping to achieve through H2OQ as a platform. Before I give an overview of driverless AI, I'd like to talk a bit about what does an AI lifecycle usually look like. Ideally, in a world as a data engineer or as a data scientist, maybe you sit down with a few business users through a bunch of meetings. You try to understand the use case and translate into how that'll become a product or how that'll become a machine learning model. And as a note, these titles are used pretty interchangeably throughout the industry. So depending whether if you're working in a startup, you could be handling both the roles of a data engineer and a data scientist and a software engineer. Or maybe these are separate depending on the scale or the setup of your industry. So once your use cases are understood, usually you'd like to find a data set, or assuming you already have a data set, you'd like to explore it, understand it before starting experiments on it, just so that you know as a data scientist which experiments you'd like to learn. And if at all it's a real world data set, real world data sets do require a lot of processing. So for that, you'll need the help of data engineers or some data engineering skills. Once you have the data set in place, you'd like to run a few experiments. Once you hit the level of happiness or accuracy in technical jargon that your business users want, you'd send it over to the application developers or software developers who will try to integrate into a software product or an app. And note that this is an iterative cycle. This is a world of software 2.0, so there's not a linear flow or there's not a defined flow. This could be a life cycle. It could be all interconnected, or it may be completely different as well. But for majority of the industries, this is how it looks like. This is where our products come into the picture. So if you look in the middle of this slide, you can see driverless AI, you can see H2O, and H2O doesn't refer to the company here, it refers to our open source framework. Towards the left, you have the Q App Store. So for the platform Q, which I had mentioned, as a data scientist, we expect driverless AI to be another tool in your tool bag and not as an AutoML tool to essentially replace you. So what's supposed to happen is through driverless AI, you'll be able to run more experiments for the different variety of problems, depending on whatever use case you're working on. It could be NLP, it could be computer vision, it could be related to tabular data, or it could be an intersection of all of these. Or if you're working as a business user, or if you're just working on the overview uh, at a very meta level of a product or life cycle, you could also interact through Q, which will add a few layers of abstraction and also have an app store where you can pick an app that really works well for your use case. So this is where driverless AI sort of fits into the complete AI lifecycle, if we can classify it as such. So instead of talking through this slide, let me actually fire up an experiment so that I don't just wave my hands that, hey, I run an experiment, I'll kick it off right now so that I won't be just waving my hands and saying, oh, I ran this in the morning. I have two instances of driverless AI up and running. This is the interface if you're new to it. So I've loaded up a few data sets and there are a couple of options to do so. I'm interested in showcasing image related data sets today. So what I've gone ahead and done is I've loaded a data set from a Kaggle competition. I'll circle back to it. I just want to kick off a few experiments. An X-ray related data set that has COVID or not COVID labels and such related labels. I want to build a model on top of it. So what I'm going to do is I'm going to hit predict here. This takes me to what I like to call personally the Iron Man dashboard. And driverless is prompting me to select the target column. Through my experiments, I know that the correct column is trying to look for it. Finding. So we're in the data set, it has a bunch of different findings about what does the image really contain. So I'm going to tone down the time and accuracy knobs. Note these aren't absolute knobs, these are just relative. And usually the default settings are good enough, but I want this experiment to run faster. So I'm going to tune down the knobs a notch so that by the time I'm done with my presentation, I can come back and showcase this. Most of the times, these settings are good enough. I just want to add a few image models. Don't worry, I'll just talk about these. I want to select one model called ResNet34, maybe another one called SERes Next 50. I'm going to save. I can see some information about what experiments are going to be run under different sets of or different parts of the pipeline. I can also visualize, diagnose my experiments, and also deploy it. I'll circle back to this later. For now, let me kick off this experiment. I have another instance running in the background. And for this one, maybe I'll go with a simpler data set where I just predict a cat, dog, or mouse. I'm going to select the labels since I'm interested in predicting the labels. I'll tune down the accuracy so that these experiments finish in time. And later I'll circle back and talk more about what's actually happening. But for now, you can see that some progress is being made. Driverless is telling me that, hey, maybe there's a leakage in the data set. And a few experiments have started. Okay, back to the presentation. So if I were to pick the different parts of the pipeline, I've actually skipped the visualization, but I've just located the data set, fed it into my pipeline, kicked off a few experiments, and after they're done, I can circle back and create scoring pipelines. A few key strengths of driverless AI. You can generate insights and visualizations even before you kick off a few experiments. We have taken care of building very robust cross-validation strategies. Our CTO Arno likes to call it a grandmaster in a box, and essentially whatever you may expect from a Kaggle grandmaster are the key strengths of driverless AI, since we have a lot of grandmasters that actually work behind the scenes on this. There's auto advanced feature engineering. So as those experiments are happening and as those tiles were rotating while I kicked off the experiment, a bunch of features are being engineered for the dataset. Towards the end, we'll have quite a few number of models which will be selected, have hyperparameter optimization done, and maybe even ensemble depending on my requirements. After that, if I want to deploy these, I can quickly download a Mojo file, which is just a jar file that I can deploy on a highly scalable server or otherwise. So this is the data pipeline. Coming back to it, it includes data procurement, preparation, and feature engineering. So these are essentially the features that start to appear inside of driverless AI. Then comes the model training. There are a lot of, there are actually a different and a wide variety of models that driverless will actually go ahead and train while we talk in the background that's happening. So these include statistical models, tree-based models, and deep neural networks. I'll also give a quick intro or an overview about what exactly even CNNs are, after which we get model outcomes, and we can even interpret these experiments. Or if you work under a highly regulated industry, you could also generate documentation out of it that you may pass on to the regulatory bodies. So a quick 101 about what is even deep learning. This is an overview of AI. AI is a very broad field, as you very well know. Deep learning comes from the term deep neural networks, and it's essentially a very small subset. Even though it's pretty famous right now, it's pretty big in the industry. You can almost see every single paper based on deep learning appear in your Twitter feed every second. It's a small subset. It's based on neural networks. So how do even ANNs work, or how do CNNs, which is what we're interested in while working with computer vision, work? I want to quickly share a video by Otavio Good. So this is a presentation. This is a snippet from a presentation by Otavio Good. The presentation is titled "A Visual and Intuitive Understanding of Deep Learning." So this is just to give a quick recap or overview of how CNNs or how these deep neural network architectures work. So this is what's happening inside of a CNN, actually quite literally happening in the driverless AI dashboard right now. A deep neural network is essentially a collection of numbers. What's happening right now is pattern recognition. Let's say this is not the case for us, but this is from the presentation. So let's say we're trying to predict if your input has the letter A or not. So right now the neural network is doing a few scans through the images and matching a template, based on which it generates a template output, or what we call a feature map. Once it has done this through different set of templates, we get a bunch of them, which we can then collect together and check if, based on the final output, if it actually contains the letter A or not. Very simplified overview, but it should give you a reminder of how CNNs work. At the end of this process, we get different sets of accuracies. And based on the highest accuracy, we predict, hey, it does actually contain the letter A. So circling back to this, a selected bunch of applications of deep learning applied to computer vision include understanding images. So you could classify your images as cats and dogs. You could, and this quite literally happens on your phones right now. You don't need a big server for this. When you're trying to take a selfie, your phone actually auto detects your face. Sometimes it enhance your features. Sometimes it just focuses on your face. That's actually a model running in your phone in real time. Or for maybe self-driving cars, as you can see in the top right image, you'd like to understand the image, quite literally every single pixel of it. So that is known as scene understanding or semantic segmentation. And if it's applied to a series of images, it essentially becomes understanding video. So this is how deep learning replaces a traditional computer vision pipeline. Below is the deep learning pipeline versus traditional pipeline on the top. You just need a CNN that'll essentially take care of feature extraction as well, and sometimes even pre-processing depending on the domain. So as I talked about, this is what a general CNN model looks like, and this is important since I'll just be talking about a different set of these that are actually supported in driverless AI right now today. So we have an image, and let's say we're trying to predict what the image actually contains. So as I had shown, the image gets passed through a set of templates or feature maps, and different set of matrix multiplications happen while this is done. Scientists are pretty fancy with names, so please ignore the scientific naming if you're new to this. What happens after a while is we essentially get a collection of these templates that have been matched. And after running this through the pipeline, we get a different set of accuracies for all of the possible options. And based on the highest accuracy, we can safely say that this image actually contains a tree based on this example. So if you'd like to know more about deep learning or computer vision, we're actually running a live course right now. You can head to our learning center at community.h2o.ai, and you should be able to find more details. We'll be running another live course post this one. So please feel free to sign up for these. These are of course free, and you do get badges also for showing off on LinkedIn or Twitter. And the slides were actually based on my module from computer vision and deep learning in the course. So different computer vision problems based on how we look at them. This is an overview of these. You have classification, semantic segmentation, classification plus localization, and object detection, plus instance segmentation. So if you look at the left image, you're just trying to classify if your image has a cat or not. In semantic segmentation, you just care about the pixels. So if I go back to the case of self-driving cars, right, you just care about what's happening inside of your image. Am I allowed to drive on this path, or is this the footpath? Am I not allowed to? Am I, as a self-driving car, not allowed to drive here? Classification plus localization. So if you'd like to not just detect the cat, but also localize it inside of your image, you can do that. Object detection, if you'd like to detect an object. So let's say your image has a different set of objects and you'd like to be able to locate them inside of it. It's called object detection. Or if you'd like to extract these, so when you run a Zoom call and you try to put a virtual background, that's what happens. You're being segmented from your background and an image is put up behind you. A bunch of industry use cases. Computer vision is actually quite widely used in the medical domains as well in healthcare. So a lot of the data sets that we work with in, not we as in us, but as deep learning practitioners, that a few data sets that we work in healthcare are X-ray images. A large variety of, or a large breadth of diseases can be easily detected through X-ray images. So that's one of the cases. You of course need to apply different CNN model. Is not just a single thing. There are a wide variety of deep learning models that you can use. You can use it for detecting defects in manufactured components. So let's say you're a company that produces, let's say, steel, and you'd like to identify defects in it so that you don't end up sending a faulty part to your customers. You can use cameras in your production line to be able to do that. In retail, you can use it to monitor your shoppers. You can automate the process of claiming repair cost based on how damaged your car is, or maybe they're just trying to rip off the insurance agency. In agriculture, it can be used for controlling weed, soil quantity, and water needs. So you can maybe just fly out a drone over your field, see if crops are doing well, see if the soil quality is up to your requirements, and maybe check if the soil needs more water. So since I don't have exact examples of different industries, I'm going to point out a few Kaggle competitions, since uh, people may not know this, but Kaggle competitions are actually run by industries for them to be able to get different values out of them. All of these are computer vision based competitions. So here's one that's actively being run right now. You essentially need to use images to be able to detect pulmonary fibrosis based on different images that exist in this data set. Now, I'm not a medical expert and I'll pretend not to be, but as far as I understood, this is a pretty important issue, since this disease is not very well understood. So as I said, it can be used in medical domain quite widely, computer vision. Or if you are a dermatologist, it can be also used for detecting melanoma, for classifying it. This is also an active competition, so these aren't competitions from history. These are pretty current problems. And just to remind you, this isn't a tool that will essentially replace a dermatologist. It will just help them iterate faster, as a data scientist would also use these tools to their benefit. Another one can be using computer vision to identify landmarks in a data set. So if you have a satellite image and if you'd like to identify data sets or different landmarks, you can do that. If you're a farmer, you can use computer vision, or this is the problem statement of this competition, using computer vision to identify and count the number of wheat heads based on just images. I had mentioned defect detection. There was a competition titled Steel Defect Detection. I think the title pretty much explains it, but if you look here closely, and this is the promise of deep learning to me, right? As a human, especially as a non-domain expert, I won't be able to understand, oh, is this a defect or is it just a microbial image? And that's where computer vision comes in handy. So we can also allow non-domain experts to be able to use these technologies for their benefit. If you're a ship trying to navigate the water, cold waters, you can use satellite images to be able to detect if it's a ship or an iceberg. If you actually look in these images, it's quite difficult to identify where a ship is versus where an iceberg is. So even as a human, it's quite a tough problem. Not that you essentially need to automate it. It's actually useful to let the machine do this part. Or if you're an airplane agency, if you're airlines, you can understand different clouds based on satellite images. But I just want to bring this competition up also because my team had won a gold prize here. But this is a problem. This is again another Kaggle competition where the data set included images of different doggies, as well as some metadata about them, and you had to actually predict how fast will a dog get adopted. And this, I assume, would be helpful to the startup or this agency so that they can actually help increase or help speed up the adoption as much as possible. So now I'll head over to the demo, but I just want to point out different set of input formats that are currently supported. So this is how I've picked up a few data sets. They contain an archive file, a zip file essentially, or a tar ball file that contains the training data, and the classes are separated by the folders. You could also have these in different CSV files that have the physical paths to the images on them, or these could include remote URLs to the images. So now I'm just talking about how driverless AI as a software expects inputs at this moment for image problems. And there are two different modeling approaches that can be taken. So driverless could convert your image to fixed embedding, which will run, which can also run just on the CPU, and it works well with mixed data types. So the competition that I had just talked about, pet adoption, it contained not just the images but also some metadata about the pets. What is their age? What is the gender? What is the breed? And if they had a previous owner, etc., etc., etc. So computer vision problems aren't independent problems all of the time, and this can be helpful in that case. Automatic image model. So here it's just image models, and you can run this on the GPU. You'd want to run this on the GPU for the speed up. And think of this as AutoML for the images data, just for the images data. After you've done that, driverless will go ahead and figure out hyperparameters and select different models. And right now, at this moment, we support classification and regression. So I had the reason I had talked about CNNs and given a quick 101 about them is here's a few, not all, a few of the CNN models that exist. Now remember the different operations that are possible in CNN architectures. As you fiddle around with those and as you change the number of layers in them, as you go deeper, as deep learning practitioners would say, different architectures come out of it. And this is based on accuracy versus, this graph is based on accuracy versus operations. So how much compute or how much of your AWS build does it take to achieve that accuracy? As you can see, as the operations or as the compute demands go up as expected, the accuracy also goes up. And there's everything in between two extremes. So depending on your use case, you'd like to pick a model. These are models, different CNN models that works well given your compute constraints, both while training the model and also while deploying this in production. We currently support a wide variety of these, and I'll quickly show them in just a minute. So if you'd also like to inspect or debug the model, Driverless AI also allows you to be able to do that. You can see heat maps. So essentially figure out which parts of the image trigger the detection. So you can make sure that a CNN or your deep learning model isn't misidentifying images based on a false feature that exists in the image. And you can also see what's happening inside of it while it does so. Once you're done, you'd like to actually be able to use this somewhere. We allow you to visualize what's happening and also extract this as a Mojo pipeline and put it on a server, ship it on a server, ship it to your business users. And here's the roadmap for driverless AI. At this moment, we support classification and regression. And somewhere in this quarter or maybe towards the end, we'll also ship support for object detection and instance segmentation. So the problems that I had talked about essentially how we look at problems. And now I'll head back to the demo that hopefully should have finished by now. Let me quickly see if there are any questions that I should be addressing right now. Okay, I don't see any questions, so I'm going to head over to the demo. But please feel free to ask any questions if you like. Okay, looks like the training is finished. And once you're done, this is what you can see on the dashboard. Hopefully both the dashboards, yes. Now I'll take a deeper dive and actually explain what's even going on right here. So as a data scientist, I showcase the different parts of the pipeline that come into the picture or come into the day of a data scientist. This is essentially data preparation. I've already loaded up these data sets as I had mentioned. This is a Pokemon dataset just for fun. This is pretty relevant today. It contains X-ray images of different COVID patients. I found all of these data sets are from Kaggle, by the way, so you can actually find these, and these aren't proprietary data sets. This is based on the pet finder competition. So I've loaded up all of these from the file system. I actually had them on my server. All I did was I pinpointed driverless to the folder where these were. And as soon as I recall, I'll showcase how you do that. Third time is a charm. It's in datasets for my server, and I can hit load. So all I need to do is click to import, and driverless actually tells me, hey, this already exists. Are you sure you want to import? No, I don't. And if you have this data set in a S3 bucket, or if you'd like to just upload it or connect your Hadoop file system, you could also do that. So we have the data engineering figured out. Now we'd like to do some exploration. So I can click on details, and it'll essentially look into the data and show me what exists inside of it, while also showing me some metadata about the data set. So for this particular data set, there's some tabular details as well. There's some metadata about the patients. And once I scroll to the end of this columns, I should also be able to see the images inside this data set. So these are the different images. I'm not a domain expert, and I'm not able to tell if these are normal or not, since these are X-ray images. But essentially, if I were to classify this part of the pipeline, I'm looking at EDA or trying to explore the data right now. So I'd just like to make sure that, okay, the data is in the format that we need it to be, and the images are displaying correctly. So sometimes you can have images as URLs in your CSV file. You could quite literally have them in folders, and the requirements may vary. Driverless AI at this moment supports both of these cases. Once I've done my EDA, maybe explored a few images, made sure all of them are there, it's not just the first row, and I'm happy with this, I'll head back to the datasets tab. And now I'd like to predict based on this. or maybe visualize. I'll skip that and head over to prediction. So as a medical startup, let's say we're trying to predict based on X-ray images, how good can we identify COVID or different problems based on that. So I know from EDA that finding is the correct column to select here. We like to call this the summer intern mode. If you're a summer intern, you can hit launch experiment, you'll get pretty promising results. But if you want to go to images tab, and now I can select the different pre-trained image recognition models that I'd like to use here. So remember the graph and the animation I had shown about different CNN models? I get to select a few here depending on my domain knowledge. I can select the ones that I know will give promising results. Let's say I want to throw in a lighter model, so I'm going to select MobileNet. I want to throw in a cutting edge one as well, so I'll select these as well. I'm going to hit done. And I'd also like to fine tune these, fine tune the pre-trained image models for image vectorizer transformers. So essentially, I'd like to train it further on my images. I can enable this. This is the part where you'd really want graphic cards, otherwise it might take a few days for your case. And let's say I'm happy with other settings. I trust Driverless AI. These few models that I had selected, Driverless will also do smart feature engineering. It'll figure out, hey, that you don't need just all of these different CNN architectures. You also need to be able to add other ones. So for the model, for the features, if I leave these on auto, Driverless will do the smart feature engineering. It'll be smart enough to be able to figure out the problems or the features. And now I can hit launch experiment, or I can play around with these three knobs. So the scorer looks good to me. I'd want to see the log losses. Now, a quick word about these. These aren't relative, so I won't get 70% accuracy of it. This is how much of relative importance I want to give to accuracy versus time. So if I cut down on interpretability, let's say I don't want my model to be very interpretable, I want it to be more accurate. Now Driverless will do more ensembling. It'll create maybe a two-level stack. If I increase interpretability, we'll create a dataset that's more interpretable, maybe less stacked, so that we can easily interpret it. And let's say I tune down the accuracy also a notch. So these look somewhat like real values that I would actually set driverless to while running an experiment. Now, if you look towards the left, we can see that it's telling me a bit about the training data size, the feature evolution, and the final pipeline, which means what will the final model include? Including the feature engineering search space. So the features that will be built by driverless aren't just simple image features. It'll actually run a search, and using a genetic algorithm, it'll try to figure out which features work best. Once I hit launch experiment, and as details start to appear here, or I can head over to an experiment that we had just done, and I'm not going to just wave my hands here. You've actually seen the experiment was recently run. Here are the details which will load eventually. So what's being prompted here is a different set of experiments that were run. So if I head back to the model that's training right now, what driverless is doing, it's trying to fine tune different set of models, different set of image models, like GBM models, all sorts of things on the data set. And I can actually hover over these different models to see which one actually includes what details. Sorry, let me refresh the screen since this is not loading. No, this is actually running on a server that's in North America and I'm in India, so hence the latency. I apologize for that. Okay, this is based on my local server, so I can maybe showcase this one. This one is on the cat dog dataset, so I'm going to find one that was on the chest X-ray. This is the one. They, I'm just trying to find the correct experiment so that I can talk about how different experiments happen in the background. So in this section of the window, we can actually see different set of experiments or models that were trained based on this data set. So as I hover over these, driverless tells me, hey, this is the variable importance, and it switches in a dynamic fashion so I can understand which variables are more important. These are synthesized parameters. So these are generated features, and I can understand which ones work better. And towards the end, we get a model that has 100 features, and driverless has figured out these work best for given scorer. And towards the right, I can see the summary of the model. This appears after we're done training. We can see the matrix as well. So you can identify which classes are being misclassified or how much of an error exists. You can look at the ROC curve or different values depending on your needs. And you can also check out the scores for all of the models that were trained and for the details. Another interesting thing that I believe we've introduced recently in driverless 1.9 is to be able to create a leaderboard. So let me actually head back to the COVID dataset. I'm going to predict again on this one. And I want to predict based on the labels. So when you want to put a pipeline into production, you can simply select, hey, I just want to ship an image model. Driverless will tell you, hey, this is what's going to happen in the background. It's going to skip failure of transformers and models. I'm fine with that. And now we'll go ahead and create a pipeline, an image pipeline. So I'm not going to train this right now since it can take a few minutes. I'm going to showcase one that I had trained just a few minutes before the webinar. I think this should be the one. Yes, it is. So here driverless has simply created a pipeline that we can put into production. If I head over to insights, it'll actually show me the details of. So I trained this on a 11 GB graphic card, hence it's a bad size. I can actually investigate the training and validation losses, the different cropping strategies. So when you're working with image models, you have different cropping strategies, optimizers, dropouts, all of these details. I can also look at the validation log loss. So if I'd like to monitor that curve. And it'll also tell me what's going in the model, what's coming out of the model, and how is the model even working. So here's the train data set. We had actually looked into this, so let's say we're happy with it. Here are the augmented images. So if I am a domain expert, I can actually tell by looking at these, maybe something is wrong here and I need to change a few expert settings. Or you're pretty happy with it and you'll continue looking at other stuff. So here are different errors. So you can try and understand where is the model going wrong, where is it mispredicting. So you can actually figure out if the data set is incorrect or if there's a problem with the setup of the experiment. After that, you can also understand what's happening inside of the model. So CNNs aren't a black box. You can actually probe into the model and understand what's happening in the background. So here, driverless is visualizing a heat map. Hey, this is what triggered the probability of 0.912, this particular part of the image. And you can actually look on it side by side with the input image as well. So I'm not a domain expert, and these were trained on very small settings in a couple of minutes. So I don't think I should probe more into it, but these are a different set of visualization or insights that I can get after I've created a pipeline and try to understand what's actually happened in the background so that it's not just a black box model that's being created and being put into production. if I want, I can also build a scoring pipeline based on this and put that into production. Or if you want, you can also download a report generated based on this. We've covered this in the past few meetups, so I'll skip that. Another example that I want to showcase before heading into the Q&A. So if you remember the pet finder competition, let me head over to the data tab. This competition actually had different set of features about the pets. So the goal here to remind you is to predict how adoptable or how fast will a pet be or a doggy be adopted. So you have different information, a bunch of information about the doggy. And you also have images. So when I create or when I train, so I've loaded a subset of this data set. And when I try to predict based on this, I'm going to actually head over to experiments since I've already done that and in interest of time. Sorry. So what will happen is initially driverless will just use the text data to build these models. And after it figures out, hey, this images as well in the data set, it'll also start to pick up images for creating these models. One last thing that I want to showcase is, and this is pretty relevant to Kaggler's. So let's say I'm working on a competition that has the goal to predict SOTA accuracies on these images. I'll hit predict, select the target column again. And this time I'm actually going to create a leaderboard. I think the name gives it away, but I'll still show what happens now. So now what's happening is I actually need to select the test data set and select the experiments, and I can score all of these experiments that driverless AI will run by itself based on smart feature engineering and different set of genetic algorithms that figure out what works best for this problem. It'll train a wide variety of models, and I'll get a leaderboard similar to Kaggle out of this about how all of these different experiments perform on a test data set I can load into it. Hence the name leaderboard. And I find this very useful for my Kaggle competition related use cases. This is what you'd want as a data scientist, to be able to maximize your performance by running as many experiments. And with a click of a button and understanding a few expert settings, you can do this, get a large number of experiments that driverless will essentially queue in your GPU or different GPUs, depending on if you have a large number of them. And you can go ahead, grab a chai, come back to it later, and have your results ready for you to be able to understand what's happening in the model. So that was a very quick overview of driverless AI 1.9 and a quick 101 about computer vision. I think we have a few minutes left, and I'm happy to take any questions.
Absolutely, Sanyam. I was waiting for you to mention chai, which you did towards the end. Awesome. Okay, we have a bunch of questions. Let's try to get to most of them. Thank you for introducing us to Great Challenges competitions. Have you ever tested with the competition data set you introduced as your AutoML solution? If you did, how was the performance?
I think I might be giving away a few secrets, but that should be fine. For older image competitions, we're actually in the gold zone of Kaggle. And if you're a student, I'll give you a spoiler as well. You can sign up for academic licenses and actually try it for yourself. But it's quite in the very competitive range. Gold medals are pretty hard. It's you get a gold medal when you get in the top 10 position of a Kaggle competition out of thousands of people.
Awesome. Is there any noise reduction and image enhancements done by driverless AI as part of pre-processing of images?
That's a great question. Yes, there is. And you can actually load up what we call recipe by yourself as well if you'd like to add add an enhancement that you know will work. Different image augmentations happen while you do this. And the insights tab that I had shown actually showcase you what's happening in the background. So you know that the correct augmentations are being applied.
Great. Have you seen any use cases around document data extraction, say a contract document or payslips, etc.?
Yes, I have in general. I'm not sure if you're working on any right now, but these are broadly classified as OCR problems, and it's a different domain in itself.
Right. How can a dashboard be used with Grafana or Tableau? Do you want to take that?
I don't think I got the context of the question.
Our audience member, if you are still here, would like more context, and then we'll come back to it. How do I deal with large images, say 4096 by 2048? Please note, downsampling causes the classification features to smooth and/or fade away.
You'd like to buy more expensive graphic cards in that case. um, there are a few augmentation techniques depending on particular domain expert you would know the best. So you'd like to figure out what augmentations work best, but it's always advisable to start with a smaller subset. So maybe you could start with just a few images instead of downsampling.
Thank you. Is there any feature engineering going on apart from the existing features?
For images, I'm assuming you're talking about images. Yes, we're also training light GBM models as well. So think of these as level 1 or level 2 ensembles that Driverless AI will actually do in the background.
Great. How does H2O, okay, it's the same question. What kind of image transformation models are used by Driverless AI?
I think this is slightly tricky because we use the word transform as for a different purpose internally. So if referring to augmentations, I think the best place to look would be the documentation. You can find out the details there since there's so many that I can just name it off the top of my head. But you can expect all of the standard techniques plus a few grandmaster secret sauces to be happening in these.
Great. Is it possible to deploy the driverless AI trained model into another environment?
Absolutely. Let me head back to the correct browser window. So once this finishes, you should see a download as a Mojo pipeline, which it's actually doing right now. It's actually building a Mojo pipeline. So what we call Mojo is essentially a jar file, which you can deploy on any platform. It's completely independent of any requirements. You don't even need Python to be able to deploy this.
Great. How can I integrate the model to Flask API or any other API? My basic requirement is to call the CSV file through the web API. You want to take that?
Sure. So as we can see, the training has just finished. And once I download, as I mentioned, the Mojo pipeline, you could use that. Or if you're in a Flask environment, you'd want to use Python, you can also download a Python scoring pipeline. So we got you covered there.
Great. Can you share if transfer learning is being applied?
Yes, it is. So when let me actually start another experiment. I love starting experiments on driverless AI. I feel like Iron Man with this dashboard. But when I was going to the expert settings, it actually allows me to enable fine tuning. Let me quickly point out the settings just so you know what I'm talking about. One moment. So when I head over to expert settings and the images tab, I can enable fine tuning, which is essentially transfer learning, or I'm also using pre-trained weights. So all of these models are not being trained from scratch. These are pre-trained models.
Cool. Where can we have the recording of the webinar? It will be sent out shortly after. Is there any annotation support by H2O? Any tools you have? Do you want to take that, Sayam?
I'm I'm not 100% sure if it's out for publicly, so I have to reserve that. But if there is, please meet me after the webinar, and I'll check with the team and let you know.
Great. How can a driverless AI work with high capacity GPUs, and does it do parallel processing with CUDA?
Yes, it does. So these would run on just one single GPU, since that's what I could afford. But if you have a large cluster of them, we do think of multi-model training as well. And driverless actually works very well with even the DGX graphic cards, which is, I think, the largest one that exists on the market. And if you'd like to deploy these on a highly scalable environment, you can also use our open source products and use H2O to deploy these highly scalable server across terabytes of RAM even. And we have had customers that have actually done that.
Great. Our last question for the session: what are the best practices to train the model?
I trust driverless AI for it. I don't trust myself so much. But if I were to give a few tips, so to speak, that I've learned through Kaggle, start small, start with a small size of your dataset, train on it, train a small experiment on it, see if that's working okay, check your hypothesis, iterate on it, add a few ideas, try to think of few interesting ideas that may or may not work at all. And train a lot of models, go through a lot of frustration, pull out a lot of hair, and pay a lot of AWS bills.
Awesome. It looks like we don't have any more questions. Any parting thoughts, Sayam, before we conclude?
Thanks to everyone for joining on a Tuesday morning, and thank you, SK, for helping host this webinar.
Great. Thank you, Sayam, for a great session. Thank you to everybody who joined us today. Like I mentioned earlier, a copy of the recording and a slide deck will be sent out shortly after. Have a great rest of your day. Bye-bye.